Welcome back. In this video, I'll be solving problem 2551, put marbles in bags. I will just go through this one a bit fast and go straight to the solution. Essentially, task is to split input array into k subarrays. And since we have to use all the elements, we essentially are looking for one, in this case, one additional split. Is it here? Is it here, here, and so on and so on? And we need to find the best and worst splits and find the difference between them. That's essentially the task. And best split is determined by sum of edge values of the subarrays. Let's call it like that. So if we split here, it's 1, the first element of this subarray, plus again 1 because it's the last element of this subarray, that's 2. And here it's 3 and 1, that's 4. So altogether it's 6. And in this case, that's the worst possible score it can have. And the best one would be if we split here. So we take 1 and 3, that's 4, and 5 and 1, that's 6, that's 10 altogether. So 10 minus 2 plus 4, 6, so that's 4. And essentially, when you think about this problem, there is a greedy approach. So we don't care about start and end elements because so left start of subarray which has the first element, we don't care about it, and the end of the subarray which has this element, we don't care about it, because it's same for the minimum and for the maximum score subarrays, because we always have to use them, because we have to always use all the marbles. So essentially, and so since k is 2, we need to find one more split, and we need to store that. So we need to try all the splits and take the best one, take the worst ones. Essentially, we can use a heap for that and store the k minus 1 values. So pretty straightforward when you understand this. So let's have the best and worst. This will store, this will be the heap for the best and for the worst values. And so we need to use all the pairs. So 1, 3, 3, 5, 5, 1, and that's all of them. And for that in Python we can use v1, v2 for v1, v2 in pairwise weights. This is the syntax. We could also zip it and so on, but this is better approach. So our potential split value is v1 plus v2 if length of best is less than, so k minus 1. So we don't want to, we just want to have one split, and if it's less than 1, we just push heap push. So to best we push v, heap q, heap push. To worst we push v, and we continue. If not, check the best, check the mean in best, and update. Let's have it here if necessary. So excuse me. So I'll use B for the best. heap q dot heap pop from the past, and if b is less than v, heap q heap q heap push on best I push v, else I have to return b. So heap q dot heap push on best b, and check mean, check worst, check k worst, v is heap q, so I pop from the worst. And also, so since I'm storing k worst, I will store minus this, so I get a max heap, and then it's easier for me to calculate. So essentially, when I store the value, I store the negative value of it. I'll take the original value because I want the biggest one essentially. So this is, let's say, max heap, but of the worst value. So, and I only put it in if worst is greater than v, then I have to heap q heap push, so to the worst I push minus v, else heap q heap push, so to the worst again minus double v, and that's essentially it. And in the end I have to return sum of best and just pass sum of worst because worst already are negative, and this should be it. Let's try it out. All looks good. Quick submit. Okay, I just have to be careful about the situation where there is a one split. So if there is a one split, then I have to return 0 because best and worst are the same. And seems to be working. Let's check time complexity. So in this example, we are going through all the pairs and neighboring pairs. So that's n minus 1. So that's O of n. And this heap push, heap, so heap push is log n. So yeah, should be n times log of k, something like this, and space should be k because we just store k elements. So let's check it. N times log n. It doesn't seem like that to me. I don't think so. Maybe Leetcode is buggy or I'm wrong, but I think these are complexities. So n times we when we push, that's log k, because we have k elements, k minus 1 elements. So yeah. Okay, if you have any questions, leave them in comments. This is the whole code. Stop if you need. And yeah, I appreciate you following this one. See you in the next one.